Hi, welcome to this presentation on network address translation. Network address translation allows a company to translate a private IP address to a public IP address and vice versa. If you do an IP config on your desktop, or if you look on your phone and look at the IP address, more than likely, if you're connected to a LAN, either through a Wi-Fi or hardwired directly to a switch, you're probably looking at a private IP address range, like a 192.168.100, dot something as an example, or 10 dot, anything. Uh, there's three different ranges of private IP addresses. You should know those all by now, but they're in the book in Module 11 if you need to review that. These private IP addresses, they're not routable on the internet. You can't go to a website if you've got a private IP address just by itself because it will not route outside your local area network. So how is it that you're able to type in www.google.com and Google magically shows up in your browser? Well, it's through this process, through the magic of network address translation that this occurs. I'm going to walk you through how this works. We've actually got two different local area networks. One here in the gold, uh, this is representative of maybe a small company, and it has some hosts and a few employees, probably a couple printers. It also has this web server that they've decided the company wants to host locally. It's got a private IP address. It's 192.168.100.30, but it wants to be able to allow the public to access this one server. So, how do you do that? Well, if you look at R1, the edge router here, let's take a look at the running configuration. Okay, this line right here, IPNAT inside source static. So this is a static network address translation. So this means that it is one IP address, one public IP address is mapped to one private IP address. In this case, we are mapping the address of the web server, 192.168.100.30, and we're mapping that to this interface here, which is a publicly routable IP address on the edge network. It's assigned by an internet service provider. It's 69.172.32.42, as you can see there. And then here under the interface configuration, we can see that we've defined the gigabit Ethernet, which is this interface here, as the IPNet inside, and this serial connection here as the IPNet outside. So what happens is if you point your web browser to 69.172.32.42, this IP address here, this router will translate that IP address to the web server, and the browser will be able to access this web server. Now, you might be thinking, well, this is one private IP address to one public IP address. So how is that saving IPv4 addresses? The answer is it's really not. Um, there's a different method that is used to conserve IPv4 addresses, and we're going to get to that over here. Let's take a look at this router's configuration. Now, this is very typical of what you would see in like a home setting. The only thing that's missing here is like a Wi-Fi access point or a Wi-Fi router, but it would work the same way. So just bear with me here. Let's take a look at the running configuration on this. Okay, so this line right here, IPNAT inside source list one. So we're tying this tying permissions to an access list, which is right down here. Access list one. We're permitting IP addresses 192.168.100.anything to be translated. And we're tying this to interface gigabit 00, which is this interface right here. Overload. We are defining our interfaces here. So gig 01, actually this one here is the NAT inside. And then gig 00 is this interface here on the outside network. We also got DHCP. And notice we're in this DHCP pool, we are not only defining the default router, which is absolutely necessary, we're also defining a DNS server, and we're pointing it to this ISP's DNS server of 69.172.32.254. Let's take a quick look at that before I open up a browser. This is the ISP. We're going to open up this server. We're on services, and DNS turned on. And notice I have an entry here for www.cisco.com. It's an A record pointing to 69.172.32.42. If you remember that IP address, that is the same IP address that is on this interface right here. So DNS, for anyone who's not familiar with domain name services, DNS servers, they take a domain name, a URL, a server name that you type into your web browser, say www.google.com. They look up the IP address for that web server, and then they pass that back to the web browser, and the web browser will go to the IP address. Everything in the internet runs on IP addresses. Without a DNS server, if you type in google.com, the web browser is not going to know what to do with that. So let's take a look. Let's open up a browser, and I'm going to go to simulation mode. I want to see if we can get this to kind of trace it. Okay. Notice, remember that I had an entry for www.cisco.com. Okay, we got some packets going on. Let's just step this through. Let's go to real time. So it looks like if we hit the DNS server, and look at that. Welcome to Cisco Packet Tracer. This is a NAT test. If we go to the server here, click on services, go to the web, HTTP services. You'll see that I put that little paragraph tag in there just to differentiate and make sure that it was working properly. So that is how network address translation works. And this system over here with the NAT overload allows you to save IP addresses, because all devices connected to this switch will share this inside global public IP address of 69.172.30.10. If I go into this PC here and go to the web browser, that goes there as well. If I go into the web browser, excuse me, into the router, want to see the translations. You can see that one of these devices is 192.168.100.10, one's .11. Just take a quick peek and see which one is which. So this is .11 is the laptop, .10 is the PC. And you see these are the translations that this Soho 1 router is using. It's translating 69.172.30.10 inside global to 192.168.100.10. It's keeping the port number so that multiple connections can be had. And port address translation saves a lot of IPv4 addresses. You can have, quite possibly hundreds of private IP addresses sharing one public, hundreds of private IP addresses sharing one public IP address. All right, so if you have any questions, I can be reached at my classroom phone or via email. And thank you for listening in.